Welcome to Eaton's Power Systems Experience Center. Here at the Experience Center, our engineers provide a safe, controlled environment for the training, testing, and demonstrating of full-scale power system problems and solutions.
In this video, we will take you through several of the things that you must consider when determining if your facility can benefit from the addition of power factor correction. We will also demonstrate several commercial and industrial solutions designed to meet your needs.
Power factor correction is the process by which capacitors are used to increase the efficient utilization of electricity within the power system. This is done by reducing the amount of reactive power drawn from the generating source. Even with the increased use of power electronics within a modern electrical distribution system, most of the loads are still inductive. This includes every standard-driven motor, fan, and pump, as well as transformers and induction furnaces. Inductive loads require two kinds of power. They need real power, measured in kilowatts, to perform the actual work of creating heat, light, motion, and so on. They need reactive power, measured in kVAR, to sustain their magnetic field. Together, these two make up apparent power. Apparent power is measured in kVA. Let us take a closer look at this. This is a diagram of the power triangle. It shows the relation between kW, kVAR, kVA, and finally power factor. Power factor is the ratio of real power and the apparent power. It measures how effectively electrical power is being used. The problem is that this reactive power doesn't perform any useful work, but it does take up some of the electrical capacity of your system.
One of the most common ways to explain how reactive power takes up system capacity is the beer analogy. If you filled a mug with beer and you weren't careful, you could fill up the glass with foam. Now let's compare this to a transformer. With the mug, the capacity is fixed and measured in ounces. With the transformer, the capacity is fixed and measured in kVA. The foam in this example would represent reactive power taking up part of the capacity of the glass or the transformer. The beer would represent the kilowatts, or the desired part. Utilities bill for kilowatts and kilowatt hours, but in some cases, they will penalize large commercial and industrial customers if their power factor is low, or in other words, if they waste kVA capacity using a lot of reactive power. Applying power factor correction is an easy way to reduce or eliminate these penalties. If a penalty is imposed, the payback may be as short as 6 to 24 months.
Capacitors draw reactive power that is equal and opposite to the reactive power drawn by inductive loads. Going back to the power triangle, if we reduce or eliminate the reactive power required by inductive loads, our power factor will be perfect or unity. This is because our kVA would consist of only real power. Therefore, the net effect of applying capacitors is that the only reactive power the generating source has to provide is the difference. In a perfect situation, this would be zero, and the source only has to provide you with real power. Fixed capacitors can be activated with motors to compensate for the reactive power needed to magnetize the windings. There are tables within Eaton's Design It Right guide that can be used to help determine the right size for these capacitors. Fixed capacitors are usually the most economical, but may not be the most appropriate for all situations.
Where loads vary, switch capacitors like this Autovar 300 or this Autovar 600 use controllers to improve the power factor as the loads are switched on and off. This is done by automatically switching groups of capacitors in and out.
For applications where faster response is required, like sawmills, car shredders, and other dynamic processes, our static switch capacitor banks are a perfect match and can respond within one electrical cycle.
For this demonstration, we will show you how simply adding capacitance to a system with a poor power factor can reduce your current and kVA while increasing your power factor. The power factor of this load starts at 0.65. By adding 30 kVAR of capacitance, the power factor is increased to 0.87. By adding an additional 15 kVAR of capacitance, the power factor is 0.97. The net effect is that the current was reduced from 97 amps to 61 amps, and the kVA was reduced from 75 kVA to 50 kVA, freeing up capacity of the upstream cables and transformer. Today, harmonics add a whole new dimension to applying capacitor banks. Without careful application, standard capacitors may resonate with the system reactance and may be physically or electrically damaged by this interaction. The Tacoma Narrows Bridge is a classic example of mechanical resonance. As you may know, the wind kicked the bridge into resonance and without proper damping, caused the bridge to collapse. An analogous situation occurs with capacitors on a power system. The harmonic frequencies, like the wind, can kick the whole system into resonance. This will result in harmonic frequencies significantly increasing and unfortunately causing equipment to fail. Therefore, if capacitors are applied on a power system with significant harmonics, another method of power factor correction may be required. One option would be to change the size of the capacitor bank and just live with a higher or lower power factor. Another option would be to make the capacitor bank into a harmonic filter. With this option, unplanned resonance can be avoided and the desired power factor can be achieved.
Power factor correction is a great way to improve the operations of your facility. However, the application of power factor correction products has become more challenging due to the increased use of harmonic producing loads. Eaton Corporation is a designer and manufacturer of these solutions with tested and trusted products and services for the largest and smallest systems.
Here at Eaton's Power Systems Experience Center, our engineers are always ready to help troubleshoot, brainstorm, and work with you to determine the right solution for your power system.
Contact us or your local Eaton representative to schedule a visit today.